Hello and welcome back to the course. So now we are coming to the core message of my whole course. So when it comes to large-scale numerical operations, NumPy is much faster than the Python standard library because we can use vectorized element-wise operations and we do not need any for loops or if statements and so on. And in this sense, so we can also save many lines of code with NumPy. In Python, we can measure the time our machine needs for the execution of code. So with the magic function timeIt, so it's called magic because it starts with a percentage sign. So there are many so-called magic functions. And timeIt runs the code multiple times and returns us the average execution time. So but now let's first import NumPy. And then we set the size of our lists and our arrays first of all to 3. So we only have 3 elements. And then we create a NumPy array with 3 elements. So the length is 3. So we have an array with 0, 1, and 2. And also we create a list with the range function and the 3 elements. As you can see now here we have our array A and our list L. And now we measure the time our machine needs to add to each element in our array the integer 2. So it's 616 nanoseconds. And the same we are doing now for the list. So we have here list comprehension. So for each element in our list, there are only 3 elements. We add 2. And let's also measure the time here. Here we have 276 nanoseconds. So you can see in a very small scale operation, NumPy is slower here than the Python standard library. And we can also try other operations like multiplication. So we multiply each element of our array by 2. So we get 659 nanoseconds, and we do the same for the list elements, multiplying by 2. And also here 270 nanoseconds, at least at a small scale with only 3 elements, NumPy is slower. Let's go on to squaring our elements. And let's see the average time for the NumPy package. So it's 557 nanoseconds, and we do the same with the list comprehension. So now obviously here with the operation squaring, NumPy is faster than the Python standard library. So before here with addition and multiplication, NumPy was 2 times slower than the Python standard library. So in the end, it also depends which operation you have. And let's also try to get the square root with the NumPy package. (876 nanoseconds), and let's do the same with list comprehension. Now again here the Python standard library is faster, so it depends on the operation, on the type of the operation. Alright, so but it seems with a very small scale that there's not really an advantage of the NumPy package, but let's increase our size of elements from 3 to, let's say, 1 million. So we have in our array 1 million elements and also in our list. And let's rerun the whole thing. So let's begin with addition. So now we have 2.23 milliseconds for the NumPy addition. Let's see what we get with list comprehension. Now we get here 92.8 milliseconds, so NumPy here was about 40 or 45 times faster than Python standard library. And let's also try the multiplication with 1 million elements. So NumPy needs on average 2.36 milliseconds. And let's try the Python standard library. Also here 92.8 milliseconds, so about 40-45 times slower than NumPy. And let's go on to squaring. 2.38 milliseconds for the NumPy package. And the list comprehension. 362 milliseconds. NumPy is about 150 times faster than the Python standard library. And last but not least, the square root. 9.41 milliseconds. And this comprehension, 217 milliseconds. NumPy is about 20 times faster than the Python standard library. So we have seen that NumPy is, when it comes to very large scale operations with thousands or millions of elements, then NumPy is really much faster. So on average about 50 to 100 times faster than the Python standard library. And it also depends on the type of operations. Alright, so this is it for the time being, and in the next session we will have a small case study where we also have a look at the performance between NumPy and the Python standard library. So hope to see you there. Bye.